Hey everyone, I'm here to show you the first preview release of the GitLab Knowledge Graph. What is the Knowledge Graph? The goal of the Knowledge Graph is to create structured, queryable representations of code repositories and tie them to the entire GitLab development lifecycle to bring maximal context to our AI features. You can think of the Knowledge Graph framework as three layers: the Code Graph Index, which indexes a single project; the SDLC Graph Index, which ties GitLab data to the code graph; and then the agents that leverage the Knowledge Graph. The initial version of the Knowledge Graph targets the IDE as we work to build a server-side version. The initial iteration supports the local Code Graph Index. To get started, let's run the installation script and install the GitLab Knowledge Graph. The Knowledge Graph will have first-class integration with GitLab directly in your IDE. You can install the GitLab workflow extension. You can then launch the GitLab Knowledge Graph web view and get insights into your entire workspace and all of your index projects in one place. The indexing is built with performance in mind for large enterprise code bases. Here's an example of the indexer indexing over 40,000 Ruby files and 10,000 JavaScript files in under 10 seconds. Once your projects have completed indexing, you can then access all of your various projects within your workspace and also get a complete visualization of your graph. You can also search for specific definitions and explore the various relationships inside of your graph. Now, the goal is not just to visualize the data, but to give the agent platform access to this graph via tools. Now imagine I'm new to the GitLab monolith project, which is a large enterprise code base, and I need to refactor this method temp OAuth email. Now we can see that the temp OAuth email is heavily tied to the user object, which has many connections and dependencies throughout this monolith code base. Here's an example of some agent output when asking what needs to be tested throughout the code base if we refactored the method in question. This agent doesn't have access to the knowledge graph. We can see it used many tool calls and identified a few files, but was vague in the exact code paths needing examination. Rather than giving the agent basic grep tools, the agent now has a complete view of your repository despite its massive size. Here we asked it to use exclusively the knowledge graph tools, and in a similar or less number of tool calls, we've identified both the direct dependencies and the transitive dependencies affected. And when we give the agent the same prompt along with all tools available, we can see that we get even more depth, including the exact line numbers of the affected dependencies. We can also leverage the knowledge graph as a data store to improve AI security agent features, especially in large code bases with many API endpoints and attack vectors. Now imagine we made a refactoring change to the NuGet package feature and forgot to use the GitLab HTTP module. This module is important because it validates any user input URLs. First, the agent runs a broad search in the knowledge graph to understand the API dependencies. Then it identifies a few suspicious methods along with a few suspicious services. Then it tries to understand how the HTTP IO module works. Lastly, it tries to build a complete call graph as requested. And after analysis, the agent identifies a server-side request forgery vulnerability. It gives us the exact endpoint affected and the vulnerability data flow, and recommends that we use the GitLab HTTP module. Thanks for watching. I hope you're excited for where we're going. You can download and try the GitLab Knowledge Graph today.